Hi, geometry. Welcome back. We are going to learn about trig functions. And I know that might sound a little bit intimidating, but it's so much fun once you like actually see what they are. You'll be like, oh, that's it. And yes, that is all it is. So you're going to learn the trig functions. And the three major trig functions are sine, cosine, and tangent. And what they are just ratios. And it's so cool. I mean, I cannot imagine how smart these people were who discovered that there's this relationship, this ratio of sides based on an angle, and that they were able to do it without a calculator. I mean, they found these, and we have calculators to help us find these ratios, and they did it without that, which is just, to me, the coolest thing ever. But we get to learn what sine, cosine, and tangent are, and you will need a calculator to do some of these. And you also get to learn what some of the major, well, not major, but often used vocabulary in word problems are, like angle of depression, angle of elevation. So you get to learn a few things in today's lesson. So let's take a look at these basic trig functions. I don't know why they're in this order, but they are. And I'm just using these notes from before because I can't edit any of them here. But here we go. So we've got sine, cosine, and tangent. Now often you'll see these written sin, but that's short for sine. Cos, but that's short for cosine. And tan, which is short for tangent. So these are the real words, but we just write sine, cosine, tangent. Okay, so the main, or one of the most important things you understand with this is that when we say sine blank, cosine blank, tangent blank, what always comes after them is an angle. And so an angle always comes after them. And we often use theta to represent an unknown angle. So instead of using x, when it's an angle we don't know, you will often see it as theta. Now it is, and that's T-H-E, theta, I think like that. Who knows? I'm terrible at spelling. But it's not wrong to write an angle as x, but you will often see it as this Greek letter theta. Okay, so anytime you see a sine, cosine, tangent, you have to have an angle. And that's what is important when you're learning about these, is that the angle is always your perspective point. So here we have triangle ABC, and it's a right triangle with acute angle A. That just means it's less than 90, angle A. The sine of angle A, the cosine of angle A, and the tangent of angle A are defined as follows. So this is where you've probably heard this popular saying, SOHCAHTOA. There are other variations of it, but I prefer SOHCAHTOA. So SOHCAHTOA, or SOHCAHTOA. Now, what do all these letters mean? Well, S stands for sine, C stands for cosine, T stands for tangent. From this angle A, from where I am standing, if I'm standing on this angle right here, this side right here is opposite me. And if I'm standing here still, this side right here is adjacent to me. And this side, across from the 90-degree angle, is, everybody? The hypotenuse. Always the hypotenuse. Always in a right triangle, the hypotenuse is across from the 90-degree angle. So from this angle, from this, if I'm standing here, the sine of A is the opposite over the hypotenuse. Now this is just something you've got to memorize. So whether you remember SOHCAHTOA, or you can look up other popular sayings that people, whatever they're called, that help people remember. But SOHCAHTOA is the one I like. So sine of A is the opposite side. That would be BC over the adjacent, or over the hypotenuse CA. Cosine is adjacent, so that A stands for adjacent over hypotenuse. So again, from this angle, if I take the cosine of this angle, I will get whatever this divided by this is, which is just so crazy to me. Tangent is TOA, opposite, so O stands for opposite, and A stands for adjacent, so no hypotenuse in tangent, which is good to know, because sometimes you're trying to find something and you don't know the hypotenuse, you can't find it. You can just use tangent, because you know, if you know the opposite and adjacent sides. So on this first page, the important thing to learn that, or to take away from it, is this idea of SOHCAHTOA, and that is what helps us with finding angles and sides and whatnot. So I want you to take a second, maybe pause the video, memorize SOHCAHTOA, write it out several times so that you get faster at it. All right, so now we're going to actually use this. So it says find sine A and sine C. So remember, A and C are angles. These are angles, because the angles always have to come after sine or cosine or tangent. Right? Each answer as a fraction and as a decimal rounded to 4 decimal places. So angle A. So from this angle, from here, if I'm standing here, sine, so I'm going to write it out, SOHCAHTOA. So sine of A, whatever, if I knew what A was, and I put sine of A in my calculator, I would get this ratio. The opposite side, so opposite over hypotenuse. So that would be the opposite side from me is across from me, so that's 40, and the hypotenuse is 85. So here it is as a fraction, and if we write it as a decimal, then I'll need my calculator, and I'll do 40 divided by 85, and it says to round to 4 decimal places, so 0.4706. There we go. Then we want to find sine of C. So sine of angle C. So I take this away, and now I'm not standing at, so yeah, yellow doesn't show up, do green. So now I'm not standing here, at A, I'm standing at angle C. So if I'm right here, okay, so from me, what is sine of C? That's still opposite over hypotenuse. But just like if you were to go to a street corner and you were to say, okay, across from me is Chipotle, and your friend is standing somewhere else and says, well, across from me is a Starbucks, well, that makes sense because you're in different positions, you're in different places. So even though these are both opposite over hypotenuse, we're in a different place now. We're standing at angle C. So what side is opposite us, across from us? 75, and my hypotenuse is 85. So here's my fraction, and then my decimal, 0.882, rounding up, 4. So that is how you use these. So take a second and go back through it if you're unsure or having a hard time understanding this. Just look back through it, you'll get it. All right, now we're going to keep going. So it says find cosine P and cosine R. So cosine of angle P means I'm standing here, and I'm going to write it out. What is there? SOHCAHTOA. So cosine is adjacent over hypotenuse. So from here, what side is adjacent to me? Adjacent means next to. So that's 5 root 5. And the hypotenuse is across from the angle Q, or the 90-degree angle, so that's 15. So that's the problem as a fraction, and then if I wanted to write it as a decimal, I could put this in my calculator, and you get 0.745, rounding up 4. If I want to find cosine of angle R, then let's say I'm standing here now, so I've moved. So what is adjacent? So cosine is adjacent over hypotenuse. So what is adjacent to me? That would be side 10. And then my hypotenuse doesn't change, so that's 15. So 10 over, I didn't need a calculator for that, is 0.6667. I'm going to just write it like that. All right, so practicing here, knowing that the angle, so like R and P, where P and R are where you are located, and that cosine is adjacent over hypotenuse. Okay, now these are used a lot in the real world. You're not going to be walking around in life and just someone hands you a triangle and like sine of 30 degrees or sine of angle A, and you have to find out what it is. You're often going to have word problems associated with these, with the trig functions. So, especially at this level. So let's practice reading this and drawing it out. It says a rope staked 20 feet from the base of a building. So the building, looks like we have a hospital here, and the base is the bottom. So it's staked 20 feet from the base. So let's hear, sorry, my dog's barking, from the base. And let's say this is right here, 20 feet. Okay, and it's staked, oh, I erased it. So it's staked here. This distance is 20 feet. And it goes to the roof and forms, okay, so it goes to the roof right there. And it forms a 58-degree angle with the ground. To the nearest tenth of a foot, how long is the rope? All right, so if I want to know how long the rope is, in my picture, that's this distance. What is that distance? Well, let's think about this for a second. Right here, I have formed a right angle. And I know only two things. I know that this is 58 degrees, and I know that this length is 20. I don't know how tall the building is, because then I could use the Pythagorean theorem, but I don't know it. And so that is what often happens. Like if you want to find the height of something, you can use trig functions. So here is how we would apply the trig functions to solving for this distance of x. We know this side. Now 220 or 258 degrees, what side is that? Is that the opposite side or the adjacent side? It's the adjacent side. This is the adjacent side, 258 degrees. The opposite side would be the length of the or the height of the building. So adjacent, and I know x, which is the hypotenuse of this triangle. So before you pick, and so this is all new, or at least with me it's new. So, or you're learning it for the first time with me. Whenever you go to decide, hey, I need sine or cosine or tangent, how do I know which one I use? This is where you have to look at what you know and say, okay, I know 20, that's adjacent to 58 degrees. And I know or I'm solving for the hypotenuse, which is x. So I'm going to use which one, whatever trig function uses adjacent over hypotenuse, or adjacent and hypotenuse. Since I know the angle, I know the adjacent side, and I'm solving for the hypotenuse. So I'm going to use cosine, because if I use sine, I would have like y. I don't know what the opposite side is. I'd have y over x. that doesn't help, right? If you did sine of 58 degrees, that's the opposite. So y, I just wrote y in there, y over x. Well, I can't have two unknowns. You can't do that. So cosine of 58 degrees equals the adjacent side, 20, over my hypotenuse x. Now this is great because I only have one unknown. Well, how in the world do we deal with this? Guess what? You can just put it into your calculator. Now, typically, like, it's not cool when you have your unknown in the denominator because you're going to have to somehow get it into the numerator because I don't want to know what something over my unknown is. Like, I don't want to know what 1 over x is. I want to know what x is. So, what I need to do is you can either multiply by x now, and I would probably just do that. Just multiply by x now so that you get x cosine 58 degrees equals 20. And then to get x by itself, you're going to divide by cosine 58 degrees on both sides. Now, these have to stick together. So hear that. This has to stick together because after your cosine or your sine or your tangent has to come an angle. There's the only time that they get separated is if you don't know the angle. If you don't know the angle, then you're going to have to move that sine or cosine or tangent over. And to do that, we use the inverses. So we'll deal with that later. But keep those together. They are stuck with each other. So that means that x equals 20 divided by cosine 58. So you get your calculator out and you do 20 divided by cosine 58. Oops. And that is 37.7. Oh, now let's go to mode. If you hit the mode button on your calculator, it has a bunch of like intimidating words, but you want to make sure that mine is the fourth line down. It says radian and degree. You want to make sure that degree is highlighted because these are in degrees. This is 58 degrees. Radians is something that you'll learn about in pre-calc, but we want to make sure this is in degrees. So then you can hit second mode, which is quit, and that goes back to your home screen. So you can make sure that you've done that correctly, and you should get 37.7. Yeah. It doesn't tell me. Oh, to the nearest tenth. Okay. So 0.7. Yep, because the next number is 4. And this is feet. So feet. That is how long the rope is. 37.7 feet. All right. So lots of information in that problem. This is just a intro to these words that you'll see: angle of elevation and angle of depression, and their definitions. So when you think of elevation, you would often think of like what is the elevation of that mountain, or an elevator, or some sort of form of that word, and that means going up. So the angle of elevation is when you are looking up. The angle of your line of sight makes your line of sight makes with a horizontal line. So this would be your angle of elevation. Now, an angle of depression, depression often is a downer, right? You're going down. So when looking down, the angle your line of sight makes with a horizontal line. So if you are up above something and you're looking down, this would be your angle of depression. So it's all about knowing like where you are, and you form this like this horizontal line, and then are you going up from that horizontal line, or are you going down from that horizontal line? So take a second, study these, and then move on with me. So here we have an example of a pilot, and she's looking at an airport from her plane. The angle of depression. Okay, so that means looking down. So that means my line of sight is here, like if I look straight out. But if I go down, depression right here is 29 degrees. Okay, so that's 29 degrees. If the plane is at an altitude of 10,000 feet. Okay, let me back up for a second. So it's important that we know that this is the angle that's 29 degrees, not like anything over here. Like, no, it's up here. It's like your line of sight here where you would be looking, and then if we were to go down from that, 29 degrees. Okay. If the airplane is at an altitude of 10,000 feet, so that's how high it is, right? So from here, this distance is 10,000 feet. Or, if you were to mirror that, if we go down here and make a right angle, this distance is 10,000 feet. Right? Because this has to be the same as this, if this is like some sort of rectangle. Approximately how far is it from the airport? How far is the plane from the airport? So what we're trying to find really is this distance right here, this red distance. What is this? So I'll make that my X, and I'll erase this so it's not confusing. Okay, so, what is that distance? Well, what do we know? What do we know? What information do we have? What do we know? We know an angle. We know 29 degrees. And so what side do we know? From that 29 degrees, if you're standing here, you're in the plane. So here we are up here. This is opposite. So we know the opposite. And what are we trying to find? Finding if this is a right triangle, the distance here, x. So we're trying to find the hypotenuse. So which trig function do we use? The one that has the opposite and the hypotenuse in it. So there it is, katoa. But I like to practice writing it. So the sine of 29 degrees equals the opposite side, 10,000, over x, my hypotenuse. So again, my unknown is in the denominator. So I want to multiply by x. So I get x sine of 29 degrees equals 10,000. And I want to do x equals 10,000 divided by sine of 29. So we get our calculators out. We do 10,000 divided by sine of 29 degrees. Holy moly. 20,626.7 feet. That is far. But not that far in an airplane. So here, that is your distance, the airplane that is from the airport. All right, so go through and review these problems. Make sure they make sense. This next page is what would have been the homework, but we're not doing that. So what we're going to do for homework are these next 2 pages of problems right here. All right, thanks guys. See you soon.